Hello everyone. Today we are going to discuss about earthquake and my topic is seismometer. A seismometer is an instrument that records and measures earthquake. Before discussing the seismometer, let us understand the term epicenter and the focus of an earthquake. A focus is a point within the earth along the ruptures of the geological fault where an earthquake originates. It is the actual place where the earthquake occurs. And epicenter is a point just above the focus on the surface of the earth. In the process of the earthquake, a huge amount of energy are released and the energy are dissipated in the form of waves known as the seismic wave. And seismic waves are divided in two parts, one surface wave and one another is the body wave. And this is a typical recorded data of an earthquake where P waves arrives earlier then the S wave and followed by a surface wave. A P wave travels at a speed of around 8 kilometers per second and S wave 7 kilometers per second, and it is surface wave which are entirely responsible for all the damage and destruction associated with the earthquake. This is a typical type of seismometers available in internet when you Google it, and this shows the working principle of a seismometer, and this is the seismogram. The older version of a seismogram used 30 years back from now, and the data written here are known as seismogram, and these are the sensors of a modern seismometers. These are the surface sensor and these are the borehole sensor. The borehole sensors are kept 100 feet below the or more beneath the ground. They record the change in velocity, records all the waves 24/7 coming from the vehicular's movement, all the noises from the surrounding, and we have to identify this and cut the earthquake event from the long data. Yes, these sensors are very sensitive and they can record your footsteps meters away from your sensors, and sometimes we can able to locate a bomb blast kilometers away sitting in our lab. These are the accelerogram which measure the earthquake based on the change in the accelerations of the wave. They are also run 24/7 but not record ambient noise data. Like the seismogram, it only records the event or the earthquake event. And these are the synthesizer or the recorder. This acts as a CPU of your desktop. It maintains data records in the E format. And this is a scene of a technological observatory where supercomputers are installed and earthquakes from all over the world are recorded here and calculate quick and automatically upload the details of the earthquake in the internet in 5 to 7 minutes of the earthquake. And this is a live view of an earthquake from the seismogram. These are the earthquake data and the wave propagation principles. Scientists have come up with some important features of the earthquake data. We have calculated the diameters of the earth, then the depth and the structures of the interior of the earth. This is the most important fact that I wanted to highlight, that the earthquake magnitude is not just a continuous growth, instead it's a logrammetric increment. Suppose a magnitude of earthquake 4 is compared to rupees 10, then the 5 magnitude earthquake is measured as 310 rupees. Similarly, if you calculate all these things, you will find an increment of around 32 times stronger than the preceding earthquake. And the most interesting question is, can we predict earthquake? Scientists are working day and night to predict earthquake. They can only know where the earthquake are likely to occur, the chances of earthquake, where, how, and the regions of the earthquake, but not when and how much size. Till now, we cannot predict earthquake. In the scientific communities, there is a good joke that only religious priests can predict earthquake, or he may. Please consult structural engineers whenever you build your dream house. Thank you.